Alright, in this video we're going to talk about the domain of an algebraic expression, and what we mean by the domain of an expression is the set of real numbers that the variable is permitted to have. Right, so in other words, what numbers can I plug in for x in this, or for whatever the variable is in this particular expression. Now normally when we're actually looking for the domain, we don't look for what numbers can we plug in, because there's a whole bunch of numbers that we're allowed to plug into the function or to the expression. Really what we look for is what numbers am I not allowed to plug in here? What numbers are going to cause some problem that makes this expression not give me a result? Right? And there's really two types of expressions where we have to do something special to figure out the domain. One of those is what we call a rational expression, which is an expression written as a fraction where we have an x in the denominator. Right? So if my expression is 1 over x, well, if you recall something about fractions, we're never allowed to have 0 in the denominator of a fraction. Right? If I had 1 over 0, that would be equivalent of saying 1 divided by 0. And dividing by 0 is not defined in mathematics. Right? That operation just does not exist. You cannot divide something by 0. Therefore, you cannot have 0 in the bottom of a fraction. So when you have a rational expression like this, a fraction where the variable is in the denominator, the domain is the set of all x values such that x is not equal to 0. Right? The denominator of your fraction can never equal 0. Right? So anytime you have an expression that involves x is in the denominator, you cannot plug in numbers for x that would make that denominator equal 0. That's not allowed. Those numbers are not part of your domain. Alright, the other type of expression where we have to do something special to figure out the domain would be a square root, or really any even root expression. A square root, a fourth root, a sixth root. Alright, so if I have the square root of x as my expression, well remember, I cannot take the square root of a negative number. Right? The square root of a negative number is not a real number. Right? So anytime I have a square root, or like I said, any even root, like a fourth root or a sixth root, my domain is going to be the set of all x values such that x is greater than or equal to 0. Right? X in this case can equal 0. I can take the square root of 0, that equals 0. Right? It's not exciting, or the square root of 0 just equals 0, but it's allowed, it's mathematically defined that the square root of 0 equals 0. And I can take the square root of any positive number, any number greater than 0, but I can't take the square root of any number less than 0. And so my domain for a square root expression is that whatever's underneath that square root has to be greater than or equal to 0. Alright? Now, this last one up here kind of combines those two. It's 1 over the square root of x. Well, the square root of x, like we just talked about, I can't take the square root of a negative number. Right? I can take the square root of 0 or anything that's positive. Right? So, but since this square root is in the denominator of the fraction, remember this first one up here says I can't have a 0 in my denominator. So in this case, I can't put a 0 in for x, because then I would have 1 over 0, and I can't have 0 in the denominator. So in this case, my domain would be the set of all x values such that x is greater than 0. Right? Notice, when it's just a square root by itself, it's greater than or equal to 0. When that square root's in the denominator, it's just greater than 0, because I can't have it equal 0, because that would give me a 0 in the denominator. Right? So that square root in the denominator kind of combines these two rules into one there, where we have the fraction and we also have the square root. All right, so those are the basic expressions where we have to do something special to find the domain. I'm going to pause the recording here and erase this and put up a few examples where we actually find the domain of some algebraic expressions. All right, so I put up here some examples where we can find the domain of these algebraic expressions. So the first one, we have 2x squared plus 3x minus 1. All right, so this one, I had it up here before, but I erased it. But the type of things we need to look at when we're looking for domain is if we have x's in the denominator of a fraction, or if we have x's underneath a square root. In this one here, we don't have either one of those things, right? We just have 2x squared plus 3x minus 1. What we have here is a polynomial expression. Well, for any polynomial expression, the domain is going to be all real numbers, right? I can plug in any number here for x, and I'm going to be able to do those calculations and get a result. Right? There's no numbers that I would plug in for x that would like break this expression and cause it to not give me a calculation or give me an answer to it. Right? So anytime you have a polynomial, the domain is going to be all real numbers. Right? So I just use a capital D as the abbreviation for domain, and then remember, for all real numbers, instead of writing out the words all real numbers, you can just put that capital R with that double vertical line there, and that's the mathematical symbol for all real numbers. Or you can write it in interval notation as all numbers from negative infinity to positive infinity. Right? That's our domain for that expression. Right? And when you're doing problems out of a textbook or online homework or whatever it is, usually they'll tell you what like how to write the answer, what notation to use, whether it's interval notation or inequalities or just that R for all real numbers. So just make sure you pay attention to that and give the answer in the appropriate form. Right? Remember, this is what we call interval notation. And if you haven't seen the video I did on interval notation, you should check that one out because it's really cool. But that's another way we can write our domains. Right? So for part B here, we have x over x squared minus 5x plus 6. So here we have a rational expression, right? It's a fraction, and I have x's in my denominator. So when I have a rational expression, remember, my denominator can never equal 0. Right? It doesn't matter what all this stuff is, whatever's in that denominator cannot equal 0. Right? So x squared minus 5x plus 6 cannot be 0. So I have to figure out, well, what numbers that I would plug in here for x would make this actually equal to 0. All right, so to figure that out, what I can do is factor that denominator. Right? Since I have an x squared here and I have a trinomial, I can try to factor that to help me figure out, well, what numbers would make this equal 0. Since it's a 1x squared, I can do the factoring of just separating that x squared into an x times x, and then I look for two numbers that multiply to equal positive 6 and add up to equal negative 5. Right? I did a video before about factoring a trinomial like this. So again, if you haven't seen that video, you can check it out to get some more detail about how to factor something like this. But this is just real quick how we do it. Right? So x and x, and then the last two numbers here are going to be two numbers that multiply to the positive 6, add up to the negative 5. So what numbers will multiply to 6 but add up to negative 5? Well, those numbers are going to be negative 3 and negative 2, right? Yeah, negative 3 times negative 2 equals positive 6. When I add a negative 3 and a negative 2, it adds up to negative 5. Right, so that's my factoring here. So now what number would make this equal 0? Well, if I plug in x equals 3, 3 minus 3 gives me 0. Right, so I get x cannot equal 3, and I also get, for this one, when x minus 2, if I plug in x equals 2, that would make that equal 0. So x also cannot equal 2. Right, so we have the set of all x values such that x is not equal to 3 and x is not equal to 2. That's our domain for that expression. Right, and if you want to check it out, check it out. If I plug in x equals 3, I have a 3 in the numerator, which is fine. But if I plug in a 3 down here, 3 squared is 9, 9 plus 6 is 15, minus 5 times 3 is minus 15. That gives me a 0. I can't have that. All right, if I plug in x equals 2 in my denominator, I get 4 plus 6 is 10, minus 5 times 2 is minus 10, also gives me a 0. Right, so these are the two numbers that if I plug them into this algebraic expression, they give me a 0 in the denominator. Therefore, those two numbers are not part of my domain. X can be any other real number that's out there. I can plug it in and I can do the calculations and get an answer. But when I plug in 3 and 2, I get a 0 in the denominator, and that's not defined. Right, so I can't have those numbers as part of my domain. I can't plug them into this expression. Right, so that's the domain using the set builder notation or the inequality notation. If you want to write this one in the interval notation, it's a little bit more complicated, but it would be all the numbers starting from negative infinity going towards 2, but not including 2, right? So remember, with the interval notation, you use the parentheses to mean that that number is not included. And then it's all the numbers between 2 and 3. Right? So remember, I can plug in 2.1 or 2.5 or 2.937. That's fine. I just can't plug in 2 or 3 themselves. So I can plug in any number between 2 and 3. And then I can also plug in any number between 3 and infinity. Right? So basically, I'm doing all the numbers between negative infinity and positive infinity, but I'm skipping over 2 and I'm skipping over 3. Right? And those get the parentheses because I'm not including those two numbers. And these little U's here, right, for when we're doing working with sets and things like that, those U's represent the union, which just means it can be anything in this set or that set. Right? So we have 3 different intervals here that we can pick numbers out to plug into this expression. I just can't use the 2 and I can't use the 3. Right? So I have to skip over those numbers. All right, so that's my interval notation for this domain here. All right, the last one we have up here, the square root of x minus 2 over x minus 5. So this one combines a square root and also a fraction. All right, so we just kind of have to do one of those at a time and then just put the results together into one single answer. So for the square root, right, remember, I cannot take the square root of a negative number. So whatever's underneath that square root, in this case the x minus 2, has to be greater than or equal to 0. Right? It's not just x has to be greater than or equal to 0, it's that entire expression under the square root has to be greater than or equal to 0. Right? So if I solve this for x by just adding that 2 to the other side, x has to be greater than or equal to 2. All right, so this is telling me I can plug in 2. If I plug in x equals 2, that gives me the square root of 0, which equals 0, and that's fine. If I plug in x equals 3, I get the square root of 1, which equals 1. That's fine. Any other number bigger than 2, when I plug it in here, I'm getting the square root of a positive, and that's fine. But if I try to plug in x equals 1, well, 1 minus 2 is negative 1, and I can't do the square root of negative 1. Right? So I can only plug in numbers that are bigger than or equal to 2 in order to be able to do that square root, right? Because I can't take the square root of a negative. Now, my other part of this, the denominator, remember, I'm not allowed to have 0 in the denominator of the fraction, which doesn't mean that x cannot equal 0 here. It's that the entire denominator, x minus 5, cannot equal 0. And if I add that 5 to the other side, I get x cannot equal 5. Right? So those are 2 parts of my domain. X has to be greater than or equal to 2, but it cannot equal 5. Right? If I plug in x equals 5 here, I get the square root of 3, which that's fine, that's a real number. But when I plug the x equals 5 in the denominator, that gives me a 0 in the denominator, and I can't have that. Right? So if I put all this together, right, it's the set of all x such that x is greater than or equal to 2, x not equal to 5. Right? So I can plug in any number that's 2 or bigger except for 5, because that gives me that 0 in the denominator. All right, so that's my domain in the set builder notation. If I were to write this in interval notation, it would look like this. So it's greater than or equal to 2, so bracket 2 comma 5, parentheses, u, 5 comma infinity. Right, so starting at x equals 2, and x can equal 2, so the 2 gets the bracket there because 2 is included, up to 5, right, skipping over 5, so not including the 5 on either side, and then all the numbers from 5 to infinity, right, that would be all the numbers that I could plug into this expression here. All right, so when you're finding the domain of an algebraic expression, again, if you have a polynomial expression where there's no fraction, where the x in the denominator, there's no square roots, then your domain is just all real numbers, and it's as simple as that. Right? If you have a fraction, then whatever that denominator is cannot equal 0, and you have to figure out, well, what values of x that I plug into this denominator would give me 0, and those are the values that x is not allowed to be. Right? If you have a square root, whatever's underneath that square root has to be greater than or equal to 0, because you're not allowed to take the square root of a negative number. Right? So both of the things you do here involve 0, but they're not the same. Right? Remember, for a square root, it's greater than or equal to 0. For the denominator, it's not equal to 0. And sometimes students get confused about, well, when do I do greater than or equal to? When do I do not equal to? Just think about what you're doing, right? A square root, I can take the square root of 0. I cannot take the square root of a negative, therefore greater than or equal to 0. Right? When I'm doing a denominator, that just cannot equal 0. Any other number in the denominator is fine. It can be positive, it can be negative, it doesn't matter. It just cannot equal 0. And so for the denominator, you do not equal to 0. Right? If you remember what you're doing here and you're looking for numbers that make this not work, then it becomes easier to remember which one is greater than or equal to and which one is just not equal to. All right, so those are a few examples of working with the domain of an algebraic expression.